Today we'll be talking about graphing exponential and logarithmic functions. So exponents and logs we know are inverses of each other. So the graphs are going to look like inverses of each other as well. So remember we talked about this 0.01 and how we flip that over 1, 0. And then this point, depending on what the problem looks like, is going to be 1 and then the base number. And then over here, it's going to be the base number and then 1. So just like we have been doing with inverses, we're just going to flip those around. You do have what we call a horizontal asymptote line at y equals 0. So take your pen or pencil and just go ahead and draw a line right across there at 0. And then straight up and down, you have a vertical one for the log. So even the lines kind of switch. All right, let's talk about how to graph these then if we actually put numbers in here, because notice both of these just have a b for the base. So example number 1 says graph y equals 2 to the x. So first we decide which one we're graphing. So we're going to graph one that looks like this, right? 2 to the x. I don't see the word log in this problem, so I'm not going to do that. So the first point I want to graph is 0, 1, right there. The next point I want to graph is 1 base number, and base number for this problem is 2. So I want to graph the point 1, 2. Then you want to create the same basic shape. So it's fewer points than we've graphed in the ones we've done so far in our notes. And then take your pen, pencil, maybe color pencil, and just go straight across there at the 0. All right, the next one is a log problem. So we're going to make sure we're looking at this upper right-hand example. And we're going to plot the point always 1, 0. So every log problem has the point 1, 0 right there. And then the next point you can see is B1. So in this case, our B is 3. So we're going to plot the point 3, 1. Create that same shape. Then take your pencil and draw a vertical line just like that. If you feel confident with this, you can try the next couple on your own and then just fast forward the video. Otherwise, I'll spend some time going through the next ones. Y equals 4 to the x, which means we're going to graph an exponential, which is the top left type of graph right over here. First point is 0, 1. Always on an exponential graph, you always have 0, 1. And then the next one is 1 base, and our base is 4. So we'll plot the point 1, 4. Create the same shape. And then create a horizontal line for the asymptote. The asymptote's kind of just like a boundary line that your graph doesn't cross. Example 4, another exponent problem. Always start exponents with 0, 1. The next point is always 1 and then the base. So in this case, 1, 3. Notice each of these exponentials have roughly the same shape. Example 5 is a log problem. Log problems always start with a point 1, 0. Then the next point is whatever the base is, followed by 1. So the base is 2. We plot the point 2, 1. Vertical line straight down the middle at 0. For problem 6, log base 5 of x, plot your point at 1, 0. We have our base of 5, which means our next point would be 5, 1. Still the same shape, just a slightly different point at the end. And come through with your asymptote line. All right. So now that we have the basic shape of each of these graphs, we're going to go ahead and transform them, which just means move them around. So let's talk about what each of these movements mean. So if you happen to have parentheses like this on this first problem, x minus 4, that is going to be an example of when you move the graph, the entire graph, to the right 4 places. So inside the parentheses like that is going to mean to the right. Example number 8, you have this x minus 6 and also a plus 2. So there's 2 changes happening here. Notice on both example 7 and 8, you have the 3. That's the base number. That's what's going to help us graph this type of stuff up here. Then once we graph it, we transform it, we move it. All right, so this minus 6 up here, it's kind of like having a little parenthesis like that. So that's going to move in the same direction. That's going to move it right 6. And then this number at the end here, the plus 2, is going to move the graph up 2. So you would take the points that you had drawn and you'd move them all up 2 and right 6. Problem number 9, the base 2 is what would help us graph the original. And then you have this minus 5 at the end. Notice the minus 5 here is different than this one. This one over here is in a parenthesis. Ours does not have a parenthesis. So no parentheses on that minus 5. That means you're going to go down 5. So really take a look at the difference between example 7 and example 9. Be really careful between those two. Also, one thing to mention, we did this first semester, but anytime you have a minus 4 and you're going right or left, it always goes the opposite direction. So right, left is always the opposite. Same thing happens right there. Up and down are normal. Positive is up, negative is down. All right, example number 10. You have a base of 4. That's going to help us graph our original graph. X plus 2, that's inside parentheses, so we're going to move that opposite direction, left 2. And the plus 1 at the end is going to move it up 1. So the parentheses moves it right or left. The number at the end moves it up or down. Example 11, the 5 is what's going to help us graph our original problem. So all I have to deal with is the minus 7. It's not in parentheses, so that means it's going to move up, down. In this case, it's down 7 because it is a negative. Example 12, the 2 will help us graph our original graph. And then the x plus 1, again, it's kind of like having little parentheses around there. So that means it's going to move right, left, but always the opposite. So this is going to move to the left 1 place. Okay, now let's put everything together. Example 13, they went ahead and graphed the original graph for you. So notice this, the graph of f of x equals 2 to the x power is below. They've plotted the point 0, 1 and then the point 1, 2 for us. And we want to graph 2 to the x plus 3. So we got to first decide what's happening with that 3. That 3 right there, it's very similar to this 7 right here. It's up all the way at the end of the problem. Plus 3 is going to mean we go up 3. So what we'll do is we'll take both of our 2 points and we'll just move them each up 3 places. 1, 2, 3. 1, 2, 3. And remember, the lines are not drawn for you, but really we know there's an invisible line right here. We'll want to move that graph, that line up 3 as well. 1, 2, 3. That way we know exactly how low our graph comes down. There we go. All right, problem 14. Again, they graphed it for us on the first one. So you have the points 1, 0, and 3, 1. Let's see what we have to do here. We're going to have to move this graph right 2 and down 4. So each of our points will move right 2 and down 4. Here we go. Right 2, down 4. Count that out carefully. This next one, right 2, down 4. right? And then remember our line that was originally here is also going to move. So we'll move our line right 2. And when you move a line up and down, if the line is already up and down, it really doesn't make a difference. So when we move our line over, it's really just going to be focused on the right on this problem. There we go. Then we'll create the rest of our graph just like that. All right, very good. Let's do 2 more problems. These time we're going to have to graph the original and then shift it. So I'll do my original, let's do our original in pink and we'll finish up in blue. So this first one, 4 to the x plus 2 plus 5. I'm just going to first graph 4 to the x. In order to graph that, we know our first point has to be at 0, 1. Our second point is at 1, 4. You can flip back to the front of your paper to make sure you're still figuring out why that is. So 0, 1 and 1b, in this case 1, 4. Then we're going to create our graph to look like this. And our asymptote line right across there. All right, now let's figure out how to shift it. This little plus 2 up here is going to tell us to move the graph left 2. This plus 5 is going to tell us to move the graph up 5. So we want to focus our attention on the 2 points and move each of those left 2 and up 5. And then to make sure we get our shape correct and we don't go down too far, we want to make sure we move this purple line as well, the asymptote line. So again, this line is moving right and left, so you don't have to move it left. If you move a line left, it doesn't change it. But we do want to make sure we move it up 5. So now our line is right there. And then you can come in and draw the rest of that graph right there. All right, nice job. Last problem, we'll do our original in pink. Again, our original graph would just be log base 2 of x. Start by plotting the 2 points. 1, 0 and 2, 1. Put the asymptote line in right here. All right, now we have to figure out what this x plus 6 does. Notice it is in parentheses. When you have something in parentheses like that, it is going to move it right, left, opposite direction of what it would seem. So plus 6 in this case actually means left 6. So we'll move our 2 dots, left 6. We'll also go ahead and move our line to the left 6. Since our line is going up and down, a movement of right or left is going to affect it. And then there's your graph right there.